Somewhere north of the Arctic Circle, buried 500 feet inside a frozen mountain, there is a room that could outlive every government, every war, and every civilization on this planet. It has no windows. It has almost no visitors. And yet it might be the single most important room human beings have ever built. Because if the sun ever unleashes a storm powerful enough to fry every satellite in orbit, if a virus ever slips past every hospital on Earth, if the crops in every field on every continent ever fail at the same time, the answer to whether humanity gets a second chance is sitting quietly inside that mountain, waiting in the dark. This is not science fiction. This is happening right now today, in more than a dozen locations scattered across the globe, and almost nobody is talking about it. So let's talk about it. Let's go inside humanity's actual backup plan for the end of the world. For most of history, when a civilization collapsed, it collapsed completely. The Library of Alexandria burned, and with it went scrolls that could never be rewritten because the only copies were the ones turning to ash. The Maya cities were swallowed by jungle, and the knowledge of an entire calendar system, an entire way of tracking the stars, very nearly vanished with them. Every collapse before the 20th century shared the same fatal flaw. Everything important was kept in one place, or a handful of places, and when those places burned, flooded, or were sacked, the knowledge died with the buildings that held it. Somewhere around the middle of the last century, a small number of scientists, engineers, and government officials started asking an uncomfortable question. What happens if it happens to us? What happens if the modern world, with all its computers and hospitals and seed varieties bred over 10,000 years of agriculture, gets hit by something it cannot recover from? And instead of ignoring the question, they started building answers. Quietly, underground, away from headlines. That effort has never really stopped, and today it spans frozen mountains in Norway, salt mines in Austria, decommissioned military bunkers in half a dozen countries, and even hardware currently sitting on the surface of the moon. Let's start with the most famous of them all, because it is the one that actually looks like something out of a movie. On the Norwegian archipelago of Svalbard, roughly halfway between mainland Norway and the North Pole, there is a concrete wedge jutting out of a snow-covered mountainside. From the outside, it looks almost like an art installation, a strange metallic doorway set into rock and ice, glinting faintly under the aurora. This is the entrance to the Svalbard Global Seed Vault, and behind that door is one of the strangest and most important rooms on the planet. Carved more than 100 meters into solid rock, past 3 separate airlock doors designed to withstand explosions, the vault holds row after row of foil packets, each one sealed and stacked on steel shelving, each one containing seeds. Not just any seeds, duplicate samples of crop varieties from gene banks all over the world. Rice from the Philippines, wheat from Syria, beans from Peru, barley strains that farmers in remote mountain valleys have been cultivating for centuries and that exist nowhere else on Earth in digital form, only in the DNA of the seed itself. The vault opened in February of 2008, built into permafrost specifically because that frozen ground provides natural, free refrigeration that should, in theory, keep functioning even if every power plant on the planet stopped generating electricity tomorrow. The temperature inside is kept around -18 degrees Celsius, cold enough to put seeds into a kind of long-term hibernation, slowing their aging process down to a crawl. Some crop varieties stored this way could remain viable for hundreds, even thousands of years. As of the most recent counts, Svalbard holds well over 1 million distinct seed samples, representing crop diversity from nearly every country on Earth, and it has capacity for millions more. Norway paid for the vault's construction, but here is the detail that makes it different from almost every other national project in history. Norway does not own the seeds inside it. Each depositing country, research institute, or gene bank retains full ownership of its own samples. Norway is simply the landlord, providing the mountain, the security, and the cold. Everyone else sends their black box copies and keeps the keys. And this is not a hypothetical insurance policy that just sits there looking impressive. It has already been used for real in a genuine emergency. In 2015, in the middle of the Syrian civil war, the gene bank located in Aleppo, one of the most important seed collections in the Middle East for wheat, barley, and lentils adapted to dry climates, became impossible to safely access because of the fighting happening around it. Researchers had to formally request a withdrawal from Svalbard, the first withdrawal in the vault's history, to rebuild collections that had been cut off by war. Boxes that had been deposited years earlier for exactly this kind of scenario were pulled from the mountain and shipped out to help researchers in Morocco and Lebanon rebuild what Syria could no longer safely maintain. That single event proved the entire concept. This was not theater. This was a working system, tested under real wartime conditions, and it worked exactly as designed. But Svalbard is only the most visible piece of a much larger puzzle, because seeds are not the only thing worth saving, and Norway is not the only country that decided to build something permanent into that same mountain range. A short distance from the seed vault, inside a separate decommissioned coal mine on the same archipelago, sits something called the Arctic World Archive. Where Svalbard preserves biological information, the Arctic World Archive preserves digital and cultural information, and it does so using a method that sounds almost old-fashioned compared to modern cloud storage. Instead of hard drives or servers, which degrade, require constant power, and can be hacked or corrupted, the Arctic World Archive stores data on specially engineered photosensitive film, a technology developed by a company called Pickle. Information is etched onto reels of this film as literal images of text and code, readable with nothing more advanced than a magnifying glass and a light source, and rated to remain stable and legible for at least 500 years, with some estimates pushing toward 1,000, all without a single watt of electricity required to keep it alive. What kind of information ends up there? The list reads like a strange inventory of what different institutions consider genuinely irreplaceable. The Vatican has sent digitized manuscripts. Brazil has sent constitutional documents and cultural records. The Bodleian Library at Oxford has contributed historical texts. Perhaps the most talked-about deposit came from GitHub, the platform used by millions of software developers worldwide, which in 2020 sent an archive containing snapshots of open-source code repositories, essentially a frozen copy of a meaningful slice of the modern software world, sealed inside the same mountain that holds the seeds of global agriculture. Governments, universities, and private companies from dozens of countries have all made the same calculation. If the digital world we depend on today were to collapse, whether through cyber attack, solar storm, or simple technological obsolescence, there needs to be at least one copy of the important parts that does not depend on that same fragile digital infrastructure to survive. That question of technological obsolescence deserves a moment of its own, because it is a threat almost nobody thinks about when they imagine Doomsday. It is not always fire or flood or war that destroys information. Sometimes it is simply forgetting how to read it. Think about how many old file formats, floppy disks, or storage media from just 20 or 30 years ago are now essentially unreadable, not because the data was destroyed, but because the machines and software required to open them no longer exist. Now imagine that same problem stretched across centuries. A digital archive is only as permanent as the technology required to decode it. This is exactly why organizations building for the truly long term, thinking not in decades but in millennia, have gone looking for solutions that do not rely on any particular piece of modern technology at all. This is where an organization called the Long Now Foundation enters the story, and their approach to the problem is genuinely unlike anything else on this list. Founded in the 1990s by a group that included musician and technologist Brian Eno, the Long Now Foundation exists to encourage long-term thinking on a scale most institutions never consider. thinking in terms of 10,000 years rather than 10. Their most famous physical project is the Clock of the Long Now, a mechanical clock designed to tick once a year, chime once a century, and keep accurate time for 10,000 years, currently being built into a mountain in West Texas. But their information preservation project, called the Rosetta Project, might be even more relevant to our story. The Rosetta Project created a physical disk, roughly the size of a small plate, made of solid nickel, with thousands of pages of text from over 1,500 human languages micro-etched directly onto its surface using a technique that requires no digital decoding whatsoever. You do not need a computer, an operating system, or a power source to read it. You need a microscope and light, the same basic tools available to civilizations thousands of years apart. A copy of that Rosetta disk actually traveled to deep space attached to a spacecraft, but we will come back to that. Let's step back onto Earth for a moment and talk about salt, because Norway's ice is not the only geological formation humans have decided is a natural fortress. Deep inside a working salt mine near Hallstatt, Austria, a location that has been mined continuously since the Bronze Age, an organization called the Memory of Mankind Project has been quietly building an archive of its own, sometimes nicknamed the Rock of Ages. Salt mines are attractive for long-term storage for reasons that have nothing to do with romance and everything to do with geology. Salt deposits are extremely stable, resistant to earthquakes, naturally low in humidity, and in many cases have remained essentially unchanged for millions of years. The Memory of Mankind Project takes a strikingly different technical approach than either Svalbard's frozen foil packets or the Arctic World Archive's photosensitive film. They inscribe information onto small ceramic tablets, fired at extremely high temperatures, using a special ceramic ink designed to survive essentially indefinitely, resistant to fire, water, and chemical decay in ways that paper and plastic simply are not. Ordinary citizens, historians, and scientists have all been invited to contribute what they consider worth preserving, from scientific data to personal reflections on what it was like to be alive in this particular moment of history, creating something closer to a time capsule for an unknown future audience than a purely scientific archive. Now, seeds and information are two enormous pieces of this puzzle, but there is a third piece that gets far less public attention despite being just as critical, and that piece is genetic diversity beyond crops. The Svalbard Vault focuses heavily on agricultural seeds, but there are parallel efforts focused on preserving the genetic material of entire ecosystems. The Millennium Seed Bank, operated by the Royal Botanic Gardens at Kew in the United Kingdom, has been collecting and freezing seeds from wild plant species since the year 2000, with a mission to preserve at least a quarter of the world's plant species, prioritizing those under the greatest threat from habitat loss and climate change. Unlike Svalbard's focus on crops humans already eat, Kew's collection includes wild relatives of food crops, medicinal plants, and species that may hold genetic traits, like drought resistance or disease immunity, that future agriculture might desperately need, but that we do not yet know we need. There is a sobering logic underneath all of this work. We are currently living through what many scientists describe as an ongoing extinction event, and every species that disappears takes with it millions of years of evolutionary problem solving that can never be recreated once it is gone. These seed banks are, in a very real sense, an attempt to press pause on that loss, freezing genetic information in time until either the habitat can be restored or the knowledge can be put to use elsewhere. At this point, you might be wondering exactly what kind of catastrophe would ever require pulling all of these different backups out at once. And this is where our niche gets to step fully into the spotlight, because some of the most serious threats these vaults are designed to survive do not come from human conflict at all. They come from space. Consider the sun. Every 11 years or so, our star goes through a cycle of increasing and decreasing magnetic activity, and during the more active phases, it occasionally hurls enormous eruptions of charged particles directly at Earth, events called coronal mass ejections. In September of 1859, one of these eruptions, now known as the Carrington event, struck Earth with enough force to set telegraph wires on fire and produce auroras visible as far south as the Caribbean. In 1859, the technological damage was limited because the technological world itself was limited, mostly to telegraph lines. Today, an event of the same magnitude would be catastrophic in an entirely different way, because our modern world runs on satellites, power grids, and electronic systems that a Carrington-level storm could potentially fry on a continental scale. Transformers that take months or years to manufacture could be destroyed simultaneously across entire regions, potentially knocking out electricity for extended periods over huge populations. This is not a distant hypothetical. In 2012, a solar storm of comparable strength to the Carrington event actually erupted from the Sun and missed Earth by a matter of days, simply because our planet happened to be in a different part of its orbit when the eruption occurred. Scientists who studied the near miss afterward suggested that had it struck directly, the resulting damage to global infrastructure could have taken years and potentially trillions of dollars to fully repair. In a world where power grids fail for months, where satellite navigation and communication go dark, cold and dark storage systems like Svalbard's permafrost vault, requiring no active power to preserve their contents, suddenly look less like a curiosity and more like exactly the kind of resilience human civilization actually needs. Then there are threats on a scale that make solar storms look modest. Asteroid impacts have already reshaped life on Earth once, ending the age of dinosaurs roughly 66 million years ago, when an object estimated at 10 kilometers across struck what is now the Yucatan Peninsula, triggering a cascade of fires, tsunamis, and a years-long global winter caused by debris blocking sunlight. Space agencies, including NASA, now actively track thousands of near-Earth objects specifically because of that history. And in 2022, NASA even carried out a full-scale planetary defense test, the DART mission, deliberately crashing a spacecraft into a small asteroid called Dimorphos to prove that humanity could actually alter the trajectory of an incoming object if one were ever discovered on a collision course. The mission was declared a clear success, shifting the asteroid's orbital period measurably. But even the best planetary defense system in the world cannot guarantee a threat will always be spotted in time. And if an impact large enough to disrupt agriculture worldwide were to occur, seed banks holding diverse, hardy crop varieties suited to radically different growing conditions could become the literal foundation of feeding a recovering population. Then there is the far rarer but far more theoretical threat of a nearby gamma-ray burst, an almost unimaginably powerful blast of radiation released by certain kinds of exploding stars or colliding neutron stars. If one occurred close enough to Earth and pointed directly at us, the radiation could strip away a significant portion of our protective ozone layer in a matter of seconds, exposing the surface to damaging levels of ultraviolet radiation for years afterward. Some researchers have even proposed that a gamma-ray burst may have contributed to a mass extinction event hundreds of millions of years ago, though this remains an area of active scientific debate rather than settled fact. Even our own planet holds threats on this scale, sitting quietly beneath our feet. Supervolcanoes, like the one lying underneath Yellowstone National Park, have the potential, on the rare occasions they erupt, to eject enough ash and sulfur into the atmosphere to trigger what scientists call a volcanic winter, cooling global temperatures and devastating agriculture across multiple continents for years at a time. The geological record shows evidence of past supereruptions doing exactly this, and while the statistical odds of one occurring in any given century remain low, the consequences would be so severe that it remains firmly on the list of events serious backup infrastructure is quietly designed to survive. Of course, Not every threat these vaults are built for comes from the cosmos or the crust. Human beings remain fully capable of creating our own doomsday scenarios, and honestly, we have gotten remarkably good at it. Nuclear conflict remains the most obvious example, not just for the direct devastation of any detonation, but for the secondary effect scientists refer to as nuclear winter, in which smoke and soot from burning cities is lofted high into the atmosphere, blocking sunlight and cooling the planet enough to collapse harvests globally, even in countries thousands of miles from any target. Pandemics represent another well-documented category, and we do not need to imagine one, because the world lived through a real and devastating example in recent memory, one that closed borders, collapsed supply chains, and proved just how quickly interconnected global systems can strain under pressure. Add engineered biological threats, the possibility of catastrophic cyberattacks against power grids and financial systems, and increasingly, the long-term risk some researchers associate with poorly controlled advanced artificial intelligence. And you start to understand why the people who plan for civilizational risk keep a genuinely diverse list of scenarios on their whiteboards, rather than betting everything on defending against just one. This diversity of threats explains why the actual physical infrastructure of backup and bunker systems around the world is so much larger and stranger than most people realize. Deep inside Cheyenne Mountain in Colorado, the United States built and still maintains a hardened military command complex, originally constructed during the Cold War, designed to withstand a direct nuclear strike, housing early warning and command systems intended to keep functioning, even if the surface above became uninhabitable. Similar hardened facilities exist in various forms in Russia, China, and several European nations, though many remain classified or only partially acknowledged publicly, serving governmental continuity functions rather than public preservation ones. Switzerland, notably, has taken this concept further than almost any other country, with regulations historically requiring that new residential construction include access to blast-resistant shelter space, resulting in a nation whose civilian bunker capacity is, per capita, believed to be among the highest on Earth. These facilities are not typically designed with agriculture or global data preservation in mind. Their purpose is narrower and more immediate government continuity and the direct survival of key populations. But they represent the same underlying instinct as Svalbard and the Arctic World Archive, an acknowledgement, made quietly by planners rather than politicians on camera, that catastrophic disruption is not just possible but plausible enough to justify serious investment. And this brings us to the newest and, honestly, the most science fiction chapter of this entire story, because at some point, a small group of engineers and space advocates asked an obvious follow-up question. If we are worried about a catastrophe affecting all of Earth simultaneously, why keep every single backup on Earth at all? An organization called the Arch Mission Foundation set out to answer that question literally, by sending human knowledge into space. In 2019, an Arch Mission payload called the Lunar Library rode aboard the Israeli Bereshit lunar lander toward the surface of the Moon. The Lunar Library was a small disk, similar in concept to the Rosetta Project's nickel disk, containing millions of pages of information, including a large portion of the English-language version of Wikipedia, thousands of classic books, and technical diagrams, all etched using a technology designed to remain readable for potentially billions of years without any power source, decoded using nothing more advanced than an optical microscope. The mission itself did not go entirely according to plan. Bereshit suffered a technical failure during its final descent and crashed into the lunar surface rather than landing gently as intended. But because the Lunar Library was built specifically to survive exactly this kind of scenario, engineers involved in the project have stated their belief that the archive likely survived the impact largely intact, meaning that right now, scattered somewhere across a stretch of the Moon's Sea of Serenity, there may be a working backup of a meaningful slice of human knowledge, sitting on another world, waiting for nobody in particular, indefinitely. The Arch Mission Foundation did not stop there. Subsequent Lunar Library payloads have flown on later missions, and the organization has publicly discussed even more ambitious future plans, including proposals to distribute archives across multiple locations on the Moon, in stable orbits, and potentially at gravitationally stable points in space, where objects can remain parked indefinitely without needing fuel to maintain their position. The underlying philosophy is refreshingly simple, even if the engineering is not. A backup that only exists on the planet it is meant to protect against destruction is not actually much of a backup at all. True redundancy means getting at least one copy somewhere else entirely, and for a species that has only just begun venturing beyond its home planet, somewhere else entirely currently means the Moon, or a spacecraft, or an orbit, rather than another continent. Which brings us, fittingly, to the oldest and most distant backup of human civilization ever created, one that was not originally built with Doomsday preparation in mind at all, but that has ended up serving exactly that function. In 1977, NASA launched twin spacecraft named Voyager 1 and Voyager 2 on a grand tour of the outer solar system. Attached to each spacecraft is a gold-plated copper phonograph record, famously known as the Golden Record, containing greetings in 55 human languages, natural sounds from Earth like thunder, whale calls, and human laughter, and 90 minutes of music spanning cultures from around the world, alongside more than 100 images encoded onto the record depicting human anatomy, daily life, and scientific concepts. The Golden Record was designed with an extraterrestrial audience in mind, a message in a bottle cast into the cosmic ocean on the off chance that another intelligent species might someday encounter it. But today, decades later, both Voyager spacecraft have crossed the boundary of our solar system and entered interstellar space, making them, quite literally, the most distant human-made objects in existence, and by extension, the most distant, most redundant backup of a small slice of human culture that our species has ever created, one that will likely continue drifting through the galaxy for hundreds of millions of years, long after the sun itself has changed. Long after Earth as we know it has been transformed beyond recognition, it would be easy, hearing all of this, to walk away with a purely reassuring message. The idea that no matter what happens, humanity has this covered. There is a plan. Everything important has been backed up. The honest truth is a little messier than that, and it deserves to be said plainly. These systems, remarkable as they are, still have real limitations. Svalbard preserves seeds, but a vault full of dormant seeds is not the same thing as functioning agriculture, and rebuilding farming systems, distribution networks, and expertise after a genuine global catastrophe would still be an enormous undertaking even with perfect seed stock in hand. The Arctic World Archive and similar digital preservation projects depend on political stability and continued funding to remain accessible and maintained. And history has shown repeatedly that institutions humans assume are permanent can quietly lose funding, access, or relevance over time. Even physical security is not absolute. Norway itself has had to reinforce and upgrade the entrance tunnel to the Svalbard Vault after unexpected meltwater, linked to unusually warm Arctic temperatures, seeped into the access corridor in 2016. A stark and slightly ironic reminder that even a vault built specifically to survive climate-related catastrophe is not entirely immune to the effects of a warming planet. And most of these projects remain concentrated in a relatively small number of wealthy nations with the resources to fund long-term preservation efforts, raising legitimate questions about whose knowledge, whose crops, and whose culture actually get preserved when the bill comes due, and whose does not. But even with all of those honest caveats on the table, there is something genuinely remarkable about what has already been built, quietly, without much fanfare. by people who spent their careers thinking seriously about scenarios most of us prefer not to imagine. Right now, today, while you are watching this, there are seeds from nearly every country on Earth sitting frozen in an Arctic mountain. There is a copy of open-source code, historic manuscripts, and constitutional documents etched onto film designed to last 500 years without electricity. There are ceramic tablets buried in an Austrian salt mine, carrying reflections from ordinary people about what it meant to be alive in this century. There is a disk on the moon, possibly cracked open on impact, but very likely still readable, holding a slice of human knowledge on a world with no atmosphere to erode it. And drifting silently through interstellar space right now, farther from home than anything else we have ever built, 2 golden records carry the sound of human laughter into the dark, on the vanishingly small chance that someone, someday, somewhere, finds them and wonders who we were. Civilizations have collapsed before. Libraries have burned before. But for the first time in the history of our species, we are not simply hopping, we survive the next catastrophe. We are actively, deliberately, quietly building the tools to come back from one. And whether that catastrophe comes from beneath our feet, from beyond the edges of our solar system, or from choices we make ourselves, the seeds, the discs, the tablets, and the golden records are already out there, waiting in the cold and the dark for a future none of us can predict, but that all of us are, in some small way, already preparing for.